So good evening all. I'm Pramod Gawal, TA of this course. So I'm going to take a problem solving session 11 on the chemical in the reaction engine course on the week 11th non-ideal reactor design. The course tutor is Professor Vishwata Mandal's Chemical Engineering Department IIT Guwahati. So I think all of you have gone through the week 11 lectures which are available on same portals. So based on that I'm going to take a problem solving. So starting from
Good
the
evening all, I'm
MCQ1.
Pramod Gawal, TA of this course.
So I'm going to take a problem. If the resident times obtained for the reactor by the RTD means the resident time distribution, experiment is less than that of expected. It indicates option given C star P bar bubbling bed reactor dead volume. The the dead volume of reactor does not contribute to the reactor functions. The entire volume of reactor is a sum of active volume and dead volume. So it's a so resident times obtained for the reactor by RTD experiment is less than that expected. It indicates the dead values. Okay. Moving to the question number 2. If the entire volume of PFR is 10 meter cube and dead volume is 2 meter cube, then the active volume of the reactor is. So volume of PFR V is equal to Vp plus Vd. Right. Here Vp is a active volume and Vd is a dead volume. So here total volume given 10 meter cube Vp we have to calculate and dead volume is 2. Vp is equal to 8 meter cube. Option C is correct. Now question number 3. Are two PFRs P1 and P2 in parallel, the exist age distribution gives. So to option given, a single peak at T equal to TP1, a single peak at T is equal to TP2 and two peaks and the corner peaks. So here two peaks are obtained. So one is a TP1 equal to VP1 day1 by V1. And second TP2 equal to VP2 divided by 5. Here V1 and V2 are the volumetric flow rate in P1 and P2 reactors. So here option is a C. Now question number 4. The variances of PFR is. So there is no mixing inside the PFR. There is no variation in the concentration in PFR. So it's a 0. The variance for C stars. So there is a complete mixing in the C star. The reactant are the uniformly mixed. Since the variance is so there is a variance in the CSTR. So there is infinity. Question 6. For early mixing, which of the following reactor combination of the reactor is used? So generally CSTR is followed by the PFR for the early mixing. This combination favor the reaction of the negative orders. Option is correct. Question number 7. The area under the curve exists a distribution integrated between t equal to 0 and t equal to infinity is option given 0 to unity and infinite. So fraction of all the component that exists the reactor after the residing inside the reactor between t is equal to 0 to t is equal to infinity is a unity. So this is based on the assumption that no tracer can remain indefinitely inside the reactors. Option C is correct. Question number 8. The resident time distribution of an ideal CSTR is. So RTD or ideal CSTR is E T equal to 1 by tau minus T by tau. Option A, math. The existence distribution curve ET for an ideal C star with the average resident time tau is given by. For an ideal C star, it equal to tau C star. Almost same question. Question number 10. The E curve for an non-ideal reactor define the fraction of fluid having edge between T and T plus dt. There, E curve is called the exist edge distribution. The E curve for a non-ideal reactor defined as a fraction of fluid having a edge between T and T plus dt as the outlet. Question number 11. A pulse tracer is introduced in a ideal C star with a mean resident time tau at a time t equal to 0. The time taken for the exist concentration of the tracer to reach half of its initial value will be. Here condition given. So here is a reactor. Yep. Pulse tracer input V volume of reactors. F is a flow rate. Is concentration of tracer. Right. Now we have to balance. So pressure balance. So V dc by dt equal to input minus output equal to Fc in minus Fc out. So here C in is a 0. No input of tracer after the pull instruction. No input of tracer after pulse injection. Right. C out equal to C. This one. So put this value above equations. V dc by dt equal to F into 0 Fc. Now rearrange it. dc by C, C naught by C equal to minus F by V 0 to T dt. Here, C naught is the initial concentration of tracer input. Right. Now integrate ln C by C naught equal to minus 1 by V by F to T. So we can write down tau is equal to V by F. So mean resident times tau. Now here in question given C by C naught equal to half. Right. Now ln half equal to minus T 1 by 2 equal to tau. So to T by 2 equal to ln 1 by 2 to tau 0.693 tau. And is question 12. For a packed bed reactor, the presence of the long tail in the resident times distribution curve is an indication of this curve 50 versus T. Like the packed bed reactor, this is a dead zone. The presence of long tail in the resident distribution curve is an indication of this one dead zone. So option C is correct. Now question number 13. The mean the conversion in exit streams for a second order liquid phase reaction in a non-ideal flow reactor is given by. So we have to calculate the mean convergence, right? To calculate the mean convergence, x equal to integrate 0 to infinity x t t dt, right? For second order reactions, liquid phase in a flow reactor for ideal conditions, T T say not equal to xa, right? Now for a non-ideal flow reactors for second order reactions, Ca equal to Ca naught 1 1 plus K Ca naught T. So this is for second order reactions non-ideal flow. We can write down 1 minus Xa equal to 1 by 1 plus K Ca naught T, right? Xa equal to K Ca naught T 1 plus K Ca naught T. The equation 2. Now based on the equation 1 and 2, based on equation 1 and 2, x equal to 0 to infinity a is a naught 1 plus a t T naught dt to dt. Now check the options. The option A is correct. Here mentioned that second order, so you can write K2. Now question number 14. The resident times distribution ET as shown in below of reactor is 0 until 3 minutes and then increase linearly to maximum value Emax at 8 minutes, after which it decrease linearly back to the 0 at 15 minutes. So what is the value of the Emax? Right. So we have to calculate the Emax. Now is distribution of the fluid equations 0 to infinity Et dt equal to 1. Right. The is distribution of the fluid. Now 0 t Et dt plus 3.0 to 8.0 Et dt plus understand 8.0 15.0 Et is b Et dt plus 15.0 to infinity dt equal to 1. So we based on this diagram we write down in this based on these equations. We write down these ones. Now this is the area of triangle A and this is the area of triangle B. This is a 0, this one 0. Right. Now so area of triangle 1 by 2 into base 8 minus 3 into E max base into height plus 1 by 2 15 minus 8 into E max, right, equal to 1. So 5 by 2 E max plus 7 by 2 E max equal to 1. So E max equal to 1 by 6. Take the option. So option E is met. Question number 15. A pulse concentrated KC1 solution is introduced as a tracer into the fluid entering a reaction vessels, having volume equal to the 1 meter cube and flow rate equal to 1 meter cube per minute. The concentration of pressure measured in the fluid leaving the vessel is shown in figure given below. The flow model parameters that feed the measures RTD in terms of one or all following mixture elements, namely volume of plug flow reactor VP, mix flow reactor VM, and dead space volume VD. So you have to calculate all the relations Vp, Vm, and Vd. So at these conditions, Vp by F equal to tau p equal to 20 seconds, right? So here is a tau p is equal to p resident times. So Vp equal to 20 into 1 by 60, right? Here is a flow rate meter per minute given, so we have to convert into seconds. So 1 by 3 meter cube, 1 by 3, right? The value of plug flow reactors. Now total volume given 1 meter cube and A 1 by 60 meter cube per second, right? Now Vp plus Vm divided by F equal to 57, these ones. So Vp plus Vm 50 into 1 by 60 to 5 by 6 meter cube, right? So Vm equal to 5 by 6 minus 1 by 3 equal to 1 by 2 meter cube, right? So we calculated Vm, Vp. Now we have to calculate Vd, dead space balance, equal to V minus Vp plus Vm. So 1 minus 5 by 6 equal to 1 by 6, right? Now check the options. So first Vp is equal to 1 by 3. Then Vm is equal to 1 by 2. Vd is 1 by 6. So this option C is correct. So I cover all the question based on the 11 chapters. So thank you all. So we will meet on next Friday on next chapters. Thank you.